Welcome to True Projects. In this video, we are going to explain about the project that is an efficient support vector machine algorithm based network outlier detection system. Before getting into the execution, first let us understand what is the project about. So think of how the internet and the communication networks have grown so much over the years. On one hand, it has brought all these amazing benefits that is faster communication, access to information, and so on. But on the other hand, this growth has opened the doors for cyber attacks to become more common and sophisticated. It is like as technology improves, the bad actors also get smarter, finding new ways to exploit vulnerabilities. And now these attacks, what we call is network intrusions or anomalies that are like red flags in a system. They are abnormal activities that can mess up how a network functions, steal sensitive data, or even bring a system down entirely. So that's where something called outlier detection comes in. Basically, it is a method to spot these abnormal activities by looking for data points that don't match the usual patterns. To make this happen, we use Network Outlier Detection System, that is NODS. Imagine that this as a security guard for your network that monitors everything going on. It uses techniques like signature based methods to catch threats we have already seen before, kind of like recognizing a criminal from their mugshot. But to catch the newer ones, that is unseen attacks, NODS relies on anomaly based methods, which are more like watching for suspicious behavior that out of ordinary. So this combination of methods is key to keep network safe because we are not just looking for what has happened in the past, we are preparing for the unexpected. So the current detection system we use for spotting threats in network aren't perfect. They have got some pretty big challenges. One of the main challenge is the scalability. Think about how much data flows through a network every second. When the volume gets really large, many systems just can't keep up. It is like trying to find a needle in a haystack that's constantly growing. So then there is efficiency and accuracy. Signature based systems which rely on patterns of attacks are great for catching what we have seen before, but they are completely blind to new unknown threats. It's like having a security system that only recognizes faces in database. Anything new slips right past it. So on the other hand, anomaly based systems are good at spotting unusual behavior, but they tend to overreact. They flag too many things as threats even when they are not, which can overwhelm administrators with the false alarms. So, these problems highlight why we need better systems. We are dealing with constantly evolving cyber threats, and the current tools aren't fully equipped to handle them. Especially as networks grow larger and more complex, what we really need is a solution that is not just accurate but also help to scale up efficiently to handle this data without compromising on detection. So, this project is all about creating a system that can catch suspicious behavior in the network traffic. So, this system is called as Anomaly Based Network Outlier Detection System, that is NODS. What it does is pretty straightforward. It keeps an eye on the flow of the data in a network and looks for anything that's out of the ordinary. Thinks of it like a security guard monitoring a crowd. Most of the people are just going about their business, but the guard is one, the lookout for anyone acting suspiciously. So when the system checks the network traffic, it classifies everything into two categories. One is normal and the other one is abnormal. That is anomalous, abnormal behavior of the data. If something looks strange or different from the usual patterns, it is flagged as anomalous, meaning it could be a potential threat. So to train and test how well the system works, here we use two datasets that are NSLKDD and CIC-IDS 2017. These datasets are the collection of real-world network traffic data with normal and attack data, so the system can learn what typical behavior looks like and how to spot them when something is off. So when we are working with the network traffic data, one of the first step is to make sure that all the data is on the same scale, meaning it is consistent and comparable. So this is where feature scaling comes in. So here we use feature normalization, that is standard scalar, which basically standardize the data. So the values are adjusted having mean of 0 and the standard deviation of 1. This makes it easier for the model to process and learn from the data without any feature dominant because of its scale. Next, we need to identify the most importance of the data, important points of the data, that is important pieces or features that will actually help the system to make better decisions. This is done using two key techniques. One is principal component analysis and correlated feature selection. PCA helps to reduce the dimensionality, so we focus on the most important features while keeping the essential information. CFS, on the other hand, it helps to pick up the features that are more relevant to detect anomalies, cutting out any unnecessary ones. And now, actually, we build the detection part. So, here the detection model. For that, we use multiple algorithms, which are support vector machine, random forest, Gaussian naive Bayes. So here we are using two key algorithms. One is support vector machine and the other one is Gaussian naive Bayes. For the comparison, we have also used the other machine learning models. These are good at classifying data into different categories like distinguishing between normal and abnormal behavior. But but before using them, we need to optimize their settings. For that, we have used random search cross validation. That is CV, random search CV. It is a method that helps us to find the best set of parameters to make the algorithm work as efficiently as accurately possible. So here we have used support vector machine and Gaussian naive Bayes for detecting the attacks, and these algorithms are hyperparameter tuned by using this technique, that is random search CV. So this is about the proposed system. Moving on to the extension. To further improve the accuracy of this project, we are incorporating the ensemble model, that is voting classifier, which is an ensemble method. Think of this like having a team of experts making decisions together rather than relying on just one person. So this voting classifier combines the predictions from multiple individual models, each bringing its own strength to the table. By doing this, it makes the final decision more robust and less prone to mistakes. This method helps to improve the overall performance of the anomaly detection system, making it even better at catching unusual network behaviors. On top of that, we have built the front end using Flash framework. This means there is a user friendly interface that allows people to interact with the system easily. It's like turning a complex system into a something anyone we can just by clicking and typing. Plus, for the security purpose, we have also added user authentication mechanism. So this ensures that only authorized users can access and use the system. It adds an extra layer of the protection. So overall, it is not just about detecting anomalies in the network, but also making sure that the system is secure and easy to use. And moving to the implementation, to implement this project, we have followed the steps mentioned in the flow of work. So first, we started by importing all the necessary Python libraries, which are pandas, numpy, scikit-learn, flask, etc. Then comes exploring the dataset part. So here we load the dataset, that are CIC IDS 2017 and also the NSLKDD dataset. This step involves understanding the features and the structure of the data so we can make informed decisions about how to process it. Then comes data processing. Here, any repeated entries in the dataset are removed to avoid skewing the model predictions. Coming to drop cleaning, here irrelevant or missing data is dropped to ensure the model works with accurate and irrelevant information. And the data is normalized. Here we use methods such as standard scaler to make sure that all features are scaled properly for the model. Coming to data visualization, here we visualize the data to identify patterns, correlations, and outliers, which can help us in better understanding the data set and guide our model building process. Then comes label encoding part. So here, categorical labels like attack types are converted into numerical values using label encoding so the machine learning model can understand them. Then comes feature selection. So here, this step involves reducing the data set to only most relevant features. Here we have used PCA, that is principal component analysis technique, which is used to reduce the dimensionality of the data while retaining the important information. Coming to CFS, it is correlated feature selection. This selects features that are most correlated with the target variable and less correlated with each other to improve model performance. Coming to splitting the data set into train and validation. So the data set is divided into two sets. One is training the model and the other one is for validating its performance. This helps us to assess how well the model generalizes to the new data. Then comes building the model. So here all the machine learning models are initialized and they are trained with the training data to understand parameters and patterns to make the predictions. Then comes evaluating. So we evaluate all the models using accuracy, precision, recall, and FN score, and we compare through the graphs. Coming to the part of front end. So here the backend logic is connected to the user-friendly interface using Flask. System includes user authentication, that is registration and login, with SQLite handling user data storage. And users, they will be giving feature values as the input in the front end, and that will be pre-processed at the back end. It will be fed with the train model. Finally, attack will be attack detected will be displayed through the front end. So this is how we have implemented the project. Moving on to the algorithms used. These are the algorithms used in this project. So here, support vector machine and naive Bayes are tuned by the random search CV, and decision tree we have used, random forest we have used, voting classifier we have used. So these are the algorithms used to train the data set for classifying the attacks. Moving on to the requirements, to implement this project, we need basic requirements, which are hardware and software. So, coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder which contains source code file. So let's open the code folder. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So here in CIC IDS 2017, we have the dataset of CIC IDS 2017. So we will be using this dataset to train the models for predicting the attacks, network attacks. And here in this folder, we have the NSLKDD dataset that is used in this project. So here we have different files of NSLKDD. This will be loaded into the project code and it will be pre-processed. And coming to the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. So here we have two Jupyter Notebook files which contains the combination of code, graphs, and outputs all in one place. It is a backend code. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So here we have two notebook files because in this notebook file, in the CIC IDS 2017, the CIC IDS 2017 dataset will be loaded and we will train all the models on this dataset for predicting the network attack. And coming to this Jupyter source file, Jupyter notebook file, we will be training all the models on NSLKDD dataset for predicting the network attacks. So these two are the backend codes. And here we have model files. These are the model files in which we have algorithm information is stored and that will be loaded into the project code during runtime of the application. And here this is the sample file in which we have test cases that we will be using in the front end for predicting the network attacks. And here we have signup.db file. This file is a database file which is used to store the user information. So this is about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open Anaconda prompt. So it is open. Give the command cd, give the space, paste the copied path, and now click on enter. So your current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. So this is the localhost and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here, click on enter. So this is the web page of the project which is displayed in the browser and this is developed using Flask framework. So we need to get registered first. Click on register and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. As we are using two data sets, we will be doing prediction for both the data sets, both the features of the data sets. So first, let's see the NSLKDD. Click on that. So here you can see parameters, right? These are the inputs need to be given. Based on the given inputs, we will be getting the prediction of the attack. Let us understand each of them. How will they be used in this project? I mean, how it will impact the attack. So the first one we have is the destination host service count. So this represents the number of services requested by the destination host. It indicates the interaction between the host and the services it attempts to access. Then we have same SRV rate. So this measures the proportion of the current service requests that belong to the same service as previous request. A high rate could indicate a potential repetitive or suspicious behavior. Then comes logged in. So this shows whether the user has successfully logged in to the system. It could be a binary value yes or no representing the login status. Then comes destination host, same SRV rate. So this is a similar to same SRV rate, but specifically for the destination host. It measures how often the destination host requests the same service, which can help identify patterns of the behavior. Then we have destination host SRV error rate. This measures the rate of service errors specific to the destination host. It helps in identifying service related problems or malicious activities. Then we have destination host service error rate. So this measures the rate of service error specific to the destination host. It helps in identifying service related problems or malicious activities. Then we have SRV error rate. This is the overall error rate for all the services, showing how often errors occur when accessing services on the network. High rates could indicate malicious activity or the system failures. Then we have error rate. It is a general error rate for the entire system. It includes any errors that may occur across network and could indicate irregular behavior or threats. Then we have flag. So this refers to the status or type of the flag set for network connections. Flags are often used to indicate the state of a connection and can indicate potential issues. Coming to count. This is the total number of events or the number of attempts for a certain action, which helps in identifying frequency patterns in network activities. Coming to destination host count, this is the count of total events or connection attempts made to the destination host. It is useful for detecting high traffic or abnormal access patterns. Coming to protocol type, it is a type of the protocol used for network connection. For example, TCP, UDP, ICMP, etc. This helps in identifying which protocol is being used in the communication. Then we have service. It is a type of service being accessed by the host, that is HTTP, FTP, or DNS. This input helps to classify the network traffic based on the service being requested. The last parameter is destination host error rate. This is the rate of the errors related to the destination host. It helps in detecting problems or potential attacks aimed at the destination system. So this is the parameters about NSL KDD dataset. So let us enter the values. I mean, let us give the input. For that, we are supposed to open the sample file. So let's open the sample file. So here in this sheet, we have test cases of NSL KDD. These are the parameters now we have. And here are the test cases that we will be giving as the input. So let's see what is the target that we have. Let's apply filter. So here we have total 4 types of attacks. Let's check with the class 0 attack. Select it, click on OK. So we are supposed to give the values. So let's try with this case where destination host SRV count is 12, same SRV rate is 0.03, and logged in value is 0. Destination host same SRV is 0.05, and then we have destination host error rate is 1. Destination host service error rate is also 1, and the next value SRV error rate is also 1, and just error rate is 1. Flag value is 5, count is 258, and here destination host count is 255. 1 is the protocol type and 44 is the service. Destination host rate is 0. Now click on predict. So this given input, it will be pre-processed at the backend and then we will be getting the prediction. So here we got the prediction as attack is detected and that attack type is DOS attack. So here class 0 refers to DOS attack. Now let's check with the one more class, that is class 1. So let's try with this case. Here the first destination host SRV count we have as 1. Same SRV rate is 0.5. Logged in value is 0. We have zeros up to flag. So let's enter zeros up to flag. Flag value is 1. Count is 2. And 255 is the host count. Protocol type is 1. 44 is the service. Destination host error rate is 0. 4, 6. Now click on predict. So this input will be pre-processed at the backend and then we will get the prediction. So here we got the prediction as there is no attack detected and it is normal. So one refers to class normal where there is no attack. Let's check with the class 2. So let's try with this case where destination SRV count is 91 and 1 is the same SRV, logged in value is 1. 0.36 is destination host same SRV rate and destination host setter rate is 0 and we have zeros up to flag. 9 is the flag count and 1 is the count. And destination host count is 255. 1 is the protocol type. 18 is service. And destination host error rate is 0.01. Now click on predict. So here we got the prediction as probe attack has been detected. So there is an attack detected and that attack type is probe attack. So class 2 refers to probe attack. Let's check with the last class 4. Click on OK. So let's try with this case. Here destination host SRV count is 255, same SRV is 1, logged in value is 1, and the next value is also 1. Destination host setter rate is 0, and then we have zeros up to flag, and flag count is 9, 1 is the count. And here destination host count is 21, protocol type is 1, 22 is service, destination host is 0. Now click on predict. So here we got the prediction that U2R is detected. So here class 4 is the U2R. So we are done with the prediction of NSL KDD dataset. So now let's do prediction with the CIC-IDS dataset. So these are the parameters of the CIC-IDS dataset. These are the parameters need to be entered now. So let's understand what are these. The first one you have is the protocol. This represents the type of the protocol used in the network connection, that is TCP, UDP, or ICMP. It is a protocol defines the rules for data transmission and can be important for identifying anomalies or attacks. Then we have packet length min. This refers to the minimum length of the data packets in the flow. It helps in identifying unusual small or large packets that could indicate unusual behavior or attacks. Then we have backward packet length min. This is the minimum packet length for packets in the backward direction from destination to the source. It can help in detecting irregularities or potential threats in the data return traffic. Then we have forward packet length min. This is the minimum packet length for packets in the forward direction from source to the destination. Monitoring this helps to detect the anomalies in outgoing traffic. Then we have initial backward win bytes. So this refers to the initial size of the backward window, that is amount of the data that can be sent before receiving an acknowledgement in bytes. It can help detect performance issues or attack patterns related to the data flow. Then we have flow IET STD. So this is the standard deviation of the inter-arrival times between packets in a flow. It gives insights into the timing of packet arrivals and can help detect irregularities in network behavior. Then we have down up ratio. So this measures the ratio of data downloaded to the data uploaded during the flow. A high ratio could indicate one-sided communication or abnormal traffic patterns. Then we have flow IET max. This is the maximum inter-arrival time between packet in a flow. A high value could suggest irregular packet timing, possibly indicating an attack or network congestion. Then we have flow IET max, that is forward IET max. This refers to the maximum inter-arrival time between forward direction packets, that is from the source to the destination. It helps in detecting delays or irregularities in the forward traffic. Coming to idle min. So this is the minimum ideal time between two packets in the flow. Low idle times could indicate a highly active or suspicious communication with, while high idle time might indicate normal traffic or delay in a response. Coming to ideal mean, so this is the average ideal time in the flow. It provides a general sense of the flow's spacing and can be useful in identifying normal or abnormal traffic patterns. Coming to idle max, so this refers to the maximum idle time between packets in the flow. A long idle time could suggest a network timeout or attack like slow deliberate probing. Then we have Forward IIT STD. So this is the standard deviation of the inter-arrival time between forward packets. It helps to identify patterns in the timing of packet arrivals in the forward direction and highlights any unusual behavior. Then we have forward IIT mean. So this is the average inter-arrival time of packets in the forward direction. It indicates the regularity of packet transmission and can help to spot the irregular communication patterns. So this is all about the parameters. Now let's give the input for these parameters. For that we have test cases, right? So in this sheet we have, let's apply filter to this and see how many classes we do have here. So total here we have 7 classes. Let's try with the class 0. So these are the inputs to be given where protocol is 6, packet length is 0, and we have zeros up to initial backward bytes. And the next one is flow IIT STD, that is, we have copied it wrongly. So yeah, this one, initial backward when bytes are 362. And the next we have flow IIT standard deviation. And then we have down up, that is down up ratio, that is 0. And then next we have flow IIT max, flow IIT min, and the next one is idle min, that is 0. So the next three values are 0. And flow IIT standard deviation, copy it, and flow IIT mean. So we have pasted it, click on predict. Here we got the prediction that there is no attack and it is benign. So there is no attack. Let's try with the class 1. So here are the test cases of class 1. Let's try with the case 1. So protocol is 6. The next three values are 0 and 277 is the initial backward when bytes. And then this is the flow IIT standard deviation. Down up is 1. Down up ratio is 1. And then we have flow IIT max, forward IIT max, copy the forward IIT max, idle min, and then we have idle mean and max are both zeros, and then forward IIT standard deviation, copy it, get back to the application, paste it, and then we have last one is forward IIT mean. Now click on predict. So this given input has been pre-processed and then we got the prediction. So here we got the prediction as botnet has been predicted. So there is an attack and the attack type is botnet attack. Now let's check with the class 2 and see what will be predicted. So these are the test cases of class 2. Let's try with the test case 1 of class 2. So we are supposed to enter all these parameters. I have entered all the details, that is all the parameters. Now let's click on predict. So here we got the prediction that is brute force attack is detected. So here the attack has been detected and that attack type is brute force. So here class 2 refers to brute force attack. Now let's check with the class 3. And these are the test cases of class 3. Now let's enter them. So I have entered all the parameters of first case of class 3. Now let's click on predict. So here we got the prediction as DDoS attack has been detected. So there is an attack and that attack type is DDoS attack. Now let's check with the class 4. Apply the filter for class 4. These are the inputs. So let's give the first case. So select the CIC-IDS prediction and here we are supposed to give in the parameters. So I have entered all the parameters of class 4. Click on predict. So here we got the prediction as DOS attack has been detected. So class 4 refers to DOS attack. Now let's check with the class 5. Let's try with this case. So here protocol is 6 and packet length are 0 and the next one is also 0. Then we have 235 as the initial backward win bytes. Flow IET copy the value and then down up ratio is 0. Flow IET max is 4620 and then we have forward IET max is 5165 and idle mean is 0. Idle max is 0 and this is also 0. And then we have forward IET standard deviation. So I've copied it. Then we have forward IET mean. Now click on predict. So here we got the prediction as there is an attack detected and that attack type is infiltration attack. So it is the infiltration attack. Here classify refers to infiltration attack. Now let's check with the last class. So select it, click on OK and now filter has been applied. Here I have entered all the details. Now let's click on predict. So here we got the prediction that attack is detected and that attack type is port scan attack. So it is the port scan attack. So this is how we need to execute. Now let's check for the graphs. Click on graph. Let's see the graphs for NSL KDD dataset. So click on that. So this is a sample outcome graph which shows the class distribution of the data. Here on x-axis we have the target class and on y-axis we have the count. So these are different classes. And here we have accuracy score comparison graph. So here on x-axis we have accuracy score and on y-axis we have all the algorithms. And these algorithms are trained on the PCA extracted features. So from the dataset we have extracted features through using PCA, that is principal component analysis. And these algorithms are trained on the PCA extracted features. And here we have precision score comparison graph. This is the recall score comparison graph. This is FN score. This is AUC. And this is false positive ratio. And this is false negative ratio comparison graph. And here we have accuracy comparison graph for the features that are extracted using CFS, that is correlation feature selection. So these are algorithms trained on this correlation feature selection technique. And similarly, here we have precision score, recall score, FN score, AUC, FPR, FNR, and that's it. So this is for the NSL KDD dataset. Similarly, we will be having for CIC ideas also. Click on that. So this is the sample outcome graph, which shows the class distribution of the target class. Here on x-axis, we have the target and y-axis, we have count. So here total, we have 7 classes. And this is accuracy score comparison graph where all the models are trained on PCA extracted features. And we have precision, recall, FN score, AUC, FPR, FNR. And here we have for the algorithms trained on the CFS, that is correlation feature selected for the CIC IDS dataset. And this is the precision score, recall score, FN score, AUC and FPR and FNR. So now click on logout. In this widgets, by giving input to the application based on the given input, we will be getting the attacks detected. If there is no attack, it will show that there is no attack or it is benign. If there is attack, it will detect which type of attack it is. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.